Hello friends, let us learn finite differences and interpolation. Finite differences. Suppose we are given with a set of values of x and y for an unknown function y equal to f of x. Then the difference is y1 minus y0, y2 minus y1, y3 minus y2, so on yn minus yn minus 1, which are respectively denoted by delta y0, delta y1, delta y2, so on delta yn minus 1, are called the first forward differences. Here delta is called the forward difference operator. Thus the first forward differences are given by delta y0 equal to y1 minus y0, delta y1 equal to y2 minus y1, delta y2 equal to y3 minus y2, so on. Now the second forward differences are differences of these first forward differences. So it is denoted by delta square y naught and is given by delta y1 minus delta y naught, delta y1 minus delta y naught. Then again delta square y1 is given by delta y2 minus delta y1, and so on. The forward difference table is given thus. So we list the values of x and then the values of y, then delta y. We just go for the difference. Delta y naught, it is denoted by, it is y1 minus y naught. Next, y2 minus y1 is delta y1. y3 minus y2 is delta y2. So on, delta yn minus 1 is yn minus yn minus 1. These are the first forward differences. We go for the second forward differences. Delta square y naught is delta y1 minus delta y naught. Delta square y1 will be delta y2 minus delta y1. It again continues. Again delta cube y, that is third forward difference. It is delta cube y naught is equal to delta square y1 minus delta square y naught. Similarly, it continues until we get the last difference. Now, the difference is y1 minus y naught, y2 minus y1, y3 minus y2. The same differences if denoted by del y1, del y2, del y3, so on up till del yn respectively, then we call them as the backward difference, and here del is called the backward difference operator. Thus del y1 is y1 minus y0, del y2 is y2 minus y1, del y3 is y3 minus y2, so on. Now similarly, the second backward differences are given by del square y2, del y2 minus del y1. Again del square y3 is del y3 minus del y2. Similarly, we go for calculating the higher order differences. Now the backward difference table is given here. X, y, again del y, del square y, we go on listing all the differences. Values of x in one column, values of y, del y. The way we take the differences is same, only the denotions change here. In forward difference, it is denoted by delta y naught, whereas in backward difference, we denote it by del y1. And calculation is same, y1 minus y naught only. Only we change the denotion here. Again, y2 minus y1, in forward difference, it is delta y1, whereas in backward difference, it is del y2. Here, it is y3 minus y2, which represents del y3 in backward difference. Now, so on it continues. Del yn means it is yn minus yn minus 1. Now, del square y, second difference is, it is del y2 minus del y1. If you take, it is denoted by del square y2. Again, del y3 minus del y2, it is denoted by del square y3, and these are the second backward differences. So on it continues. Now let us see the interpolation. Now the process of finding the value of y corresponding to any value of x between x naught to xn for a given set of values of x and y is called interpolation. That is, you are given with the set of values that x takes and the respective values that y takes for an unknown function again. Now, if you want the value of y for any value of x lying between x naught to xn, for any value lying between x naught to xn, if you want to find the value of y, that is called as interpolation. And even for values of x lying outside this interval, we can find the value of y, and that is called as extrapolation. However, in general, whether it is extrapolation or interpolation, we use the general term that is interpolation. Now, let us know the Newton's forward interpolation formula. Now, suppose an unknown function y equal to f of x takes the values x and y. Again, x takes the values x naught, x1 equal to x naught plus h, x2 equal to x1 plus h, so on. Y takes the corresponding values y naught, y1, y2, so on, for equally spaced values of x. So we should see that the values of x are equally spaced. That is, difference between x1 and x0 will be same as difference between x2 and x1. In general, the difference between any two consecutive terms of x will be same in this set of values. Now, for any real p, the value of y at x equal to x naught plus ph. Here x1 is x naught plus h, x2 can be written as x naught plus 2h, so on. So we want a value of y at x equal to x naught plus ph, where p is some real value. Then the Newton's forward interpolation formula is given by yp is equal to, that is y at p, it is y naught plus p into delta y naught plus p into p minus 1 divided by 2 factorial delta square y naught plus p into p minus 1 into p minus 2 divided by 3 factorial delta cube y naught plus so on. It continues until we have p minus 1, p minus 2, so on up till p minus of n minus 1, the last value, divided by n factorial into del raised to n y naught. And here in the forward interpolation formula, p is given by x minus x naught divided by h. X means for what value we are finding, we want y at x, this x, we want y at some value x, that x here, x naught is the first value in the table, then divided by h. H is the difference between any two values of x. So that is Newton's forward interpolation formula. Now, the Newton's backward interpolation formula. Now, suppose again we have an unknown function y equal to f of x taking values y naught, y1, y2, so on, for the values of x, x naught, x1 equal to x naught plus h, x2 equal to x naught plus 2h, so on. Then the Newton's backward interpolation formula to obtain y at x equal to xn plus ph is given by y equal to yn plus p into del yn plus p into p plus 1 divided by 2 factorial del square yn plus it continues so on p plus 1, p plus 2, so on up till p plus n minus 1 divided by n factorial multiplied by del raised to n yn, where p is any real number given by x minus xn upon h in the backward interpolation formula. So you should know that in backward interpolation formula we add these p plus 1, so on. In forward interpolation formula we have p minus 1, so on, and here it is del yn, del square yn, so on terms. In forward it is delta y naught, delta square y naught, so on. Okay, and remember the values of p to be taken for forward and backward interpolation formulas. In forward interpolation formula, P is given by x minus x naught, that is the first value of x, divided by h, whereas for backward interpolation formula, P is given by x minus xn, the last value of x, divided by h. That is Newton's forward and backward interpolation formulae.